The question is asking to draw out all constitutional isomers for C4H10O. Since this chemical formula fits in the general formula of CnH2n plus 2O, that means C4H10O can be an alcohol, which has a OH functional group. It can also be an ether, which has an oxygen sandwiched between two carbons. We're going to use a systematic way to draw the isomers, that way we won't accidentally leave out any structures. So let's start by drawing a 4-carbon chain, meaning 4 carbons connected straight in a row, and we place the OH on the first carbon. That will give us our first structure. There's another place where we can move the OH group, which is on the second carbon. Now these are the two 4-carbon chain alcohols. If we place OH group on the third carbon, it'll be the same as the second structure that we have drawn. Also, if we were to move the OH all the way to the end on the fourth carbon, it will be actually the same as the first structure. So it looks like we have exhausted all possibilities for the 4-carbon chain alcohol. In that case, let's move on to 3-carbon chain. Since we have 4 carbons total, let's place the extra carbon on carbon 2 like this. The reason we don't want to stick that 4th carbon at the end is because then we will end up with 4-carbon chain rather than 3-carbon chain. So okay, now let's stick the OH group on the first carbon like this. Keeping the same 3-carbon chain, let's move the OH to the second carbon, like that. That gave us another isomer. Now if we were to move the OH to the third carbon, it'll be the same as placing OH on the first carbon. That means we are now done with the 3-carbon chain alcohol. Since it's not possible to have a 2-carbon chain with 4 carbons, let's move on to drawing ethers. We'll do it the systematic way as well. We will start with 1 carbon, followed by oxygen and 3 remaining carbons. That's one way of drawing the ether. Keeping 1 carbon before oxygen, let's see if there's a different way we can draw the 3 carbons at the back. In fact, there is. We can have 2 carbons and then we stick the extra carbon on carbon 1 like that. Since there's no other way to drawing the 3 carbons at the back, let's just move on to placing 2 carbons before the oxygen. So we have 2 carbons, oxygen, and then 2 remaining carbons. Since there's no other way of drawing the 2 carbons at the back, that's all that we have. Here are the structures after placing in the hydrogens. We have a total of 6 isomers for C4H10O, where 4 of them are alcohols and 2 of them ethers. I hope you find the video helpful. Do subscribe. Thanks for watching, and I'll see you in the next video.